This section is over chapter 12, and 12.1 is the arithmetic of equations. And the key things that we learned in this section are how to balance equations for a recipe, how chemists use balanced equations and how we can use them, what quantities can you interpolate a balanced equation, and what quantities are conserved in every chemical reaction. And it just tells us how using everyday equations helps us in this world. Like, for example, chemists need to know how much reactant is needed to make a certain amount of a product. And the answer lies in a chemical equation. From a balanced chemical equation, you can determine the quantities of reactants and products in a reaction. So, a balanced chemical equation provides the same kind of quantities information that a recipe does. So that's how those two are kind of related and similar. And when using balanced chemical equations, the chemical equations are used as a basis to calculate how much reactant is needed or product is formed in the reaction. So we just worked through that chapter and we worked through interpreting the chemical equations and what they mean, determining the number of atoms, the number of molecules, and the moles, mass, and volume in a chemical equation. And then we figure out that the mass conservation in chemical equations and the mass and atoms are conserved in every chemical reaction. So we can determine that. And then as we move on to 12.2, this is how we are dealing with actual chemical calculations. And we write and we use mole ratios, which we already know how that is set up. And in chemical equations or chemical calculations, mole ratios are used to convert between moles of reactant and moles of product, between moles of reactants or between moles of products. So it just teaches us how to set it up to convert over. And we learned in this section how mole ratios are used in a chemical calculation and what the general procedure for solving this problem and how to do it. Then it just goes through and we learned how to calculate the moles of a product and calculating the mass of a product. And it just goes more into depth into the calculation part, and it gives us the steps in solving a mass to mass problem, which all the masses and calculation problems can get confusing, so it helps if you look them over. And then it just gives us other calculations and how to convert them and figure out their reactants. For example, calculating molecules of a product or the volume to volume style geometric calculations, and then going into finding the volume of a gas needed for a reaction. So that kind of covers that chapter into depth, just finding the reactions and calculations for each and every one. And then we go into 12.3, which is limiting reagent and percent yield. And here we learn how the amount of a product in a reaction is affected by an insufficient quantity of any of the reactants used. And we learn what the percent yield of reaction measure is. So, in a chemical reaction, an insufficient quantity of any of the reactants will limit the amount of a product that is formed. So we learn what limiting a reagent is and the excess reagent, which will help us with that. And then some sample problems would be determining the limiting reagent in a reaction, and it teaches us how to do that and to calculate and solve for the unknown, and also for using a limiting reagent to find the quantity of a product, which we list the unknowns and the unknown, and then we solve for the unknown, which we don't know. So that kind of takes us through that until we get to the percent yield, which it helps us set up the correct formula for that. The theoretical yield, the actual yield, and which leads to the percent yield. And that takes us to the percent yield is the measure of the efficiency of a reaction carried out in the laboratory. So that kind of explains what it is and what we're using for that. And so that is kind of the overall gist for this section and what we went through.